All right, so the standard form of a quadratic function is y equals a x squared plus bx plus c. Y equals a x squared plus bx plus c. That is standard form. Vertex form is y equals a x minus h squared plus k. And then it says define the following key terms and give the formulas for both. So the axis of symmetry is the line that cuts the parabola in half. The equation in standard form is x equals negative b divided by 2 times a. The equation in vertex form is x equals h. The A, H, and K, as well as B and C, help give us key information. So yesterday when we did our review, we identified A, H, and K and talked about what they did to our graph. So a positive A value tells me that my graph is open up. And that tells me that my graph has a minimum. A negative A value tells me that my graph is reflected. That means it's going to open down. That means my graph has a maximum. The H value tells me my horizontal movement. So it tells me if the graph goes left or right. And the K value tells me my vertical. So it's my up or down. The K value also gives me the range / min value or max value. So the K value helps with the range, min, max. So what is the vertex? The vertex is the highest or lowest point on the curve. The equation is h comma k or negative b divided by 2a and then plugging that number in. So for example, it says describe the transformations of a quadratic function that has the vertex 3, 4. So it tells me that my h value is 3, and h value of 3 tells me that the graph went right 3 units. My k value is equal to 4. That tells me that the graph went up 4. So in vertex form, my equation is y equals, we don't know our a, x minus 3 squared plus 4. That would also tell me that the range is either going to be less than or equal to 4 or greater than or equal to 4. Okay, some of you said yesterday you struggled on 7, 8, 9, and 10 in the homework. So that was where they gave you a vertex and they gave you a point. So if it says find the equation of the parabola in vertex form, the first thing we are trying to do is this tells me I need to find A. I'm looking for A. So it's vertex form. So that means I'm using, so I'm going to find A and use y equals A x minus h squared plus k. So I'm going to plug in for h, k, x, and y. So the vertex is my h and k. The point is my x and y. So I have 3 equals, I'm looking for A, x, which is 1, minus h, which is a fourth, squared, minus k, which is 3/2. So the first thing we want to do is try to isolate our A. So I'm going to add 3/2 to both sides. So 3 plus 3/2 is 4.5, or as a fraction, 9/2. That equals A, and then 1 minus a fourth is 3/4. And order of operations says I have to square, so then we have 9/2 equals, well, 3/4 squared is going to give you 9/16 times A. So you have two choices. You can either divide both sides by 9/16 or you can multiply by your reciprocal. So dividing by 9/16 or multiplying by your reciprocal is the same thing. So it isolates your A, also cancels the 9s on the left. 16 divided by 2 is 8. So I get A is equal to 8. So now it said to find the equation of the parabola in vertex form. Well, the equation of the parabola in vertex form is this blue. So we're going to fill in A, H, and K. So there's my final answer. So I have to find A, to get my equation. I think these are probably the most difficult part of tomorrow's test. I honestly don't remember because I wrote it last week on Friday. Okay, determine A and K so the given points are on the graph. So once again, we have 2 points on our graph. So we're going to use those to find our missing pieces. So these are kind of like my X and Y's. So we have 1 equals A, 0 minus 1 squared plus K. So you get 1 equals A plus K. So this goes back to using systems of equations. So A plus K has to equal 1. So then we're going to use our other X and Y point. So I have 1 equals A, 2 minus 1 squared plus K. And what you'll notice is you get the same thing. 1 equals 2 minus 1, which is 1, 1 squared, A plus K. So this is set up in a way that you can have a billion different answers as long as whatever you plug in has A equaling 1 when added to K. So that's kind of like saying A is equal to 1 minus K. So if I make K equal to 3, A is going to equal 1 minus 3, or negative 2. So that would give me the equation y equals negative 2, x minus 1 squared plus 3. But somebody else could have said, well, I want A to equal 2 instead of negative 2. So then you get 1 equals 2 plus K. So this time, K is negative 1 when A is 2. So you have a different equation. So it just says find an A and a K that make this true. There are a multitude of A's and K's that would work. So it's kind of like the one question I gave on your homework that said, give me a value that would make this graph a max. So similarly, if I said pick an A value that makes this graph a max, well, then you need your A value to be the orange equation. So I said pick an A value that makes the graph have a min, well, now you need the red. So it's being able to decipher that information to make a statement true. And finally, this is the key ideas. There's probably about 3 of these. You have to be able to take an equation and fill out all of the information as well as graph it. So this equation is the easier of the 2 forms. This is vertex form, which means you can see H and K in the equation. So my vertex is negative 1, positive 1. The axis of symmetry is always x equals h. So it's x equals negative 1. My A value is negative. So if my A value is negative, my graph is open down. Therefore, I have a max. The max is at K. So it's at 1. The domain of all quadratics is always all reals. Yes.
You have to say all reals or the R.
You can do the R. Yep. So you can write the words. You can do the double R. You can do the negative infinity to infinity. The range, so this graph is reflected, right? So if the graph is reflected, it's open down. So my y values are less than or equal to k, which is 1. Let's put that into words. So if it is -1, +1 for the vertex, that is left 1, up 1, and the -2 tells me it's stretched by 2. That means it's going to be narrow. And the negative tells me it's reflected. So let's create our table. So your table is x plus h, which in this case is -1, y times a plus k. So the 0, 1, 2, and 0, 1, 4 never change. So my x's are at -1, 0, and 1. My y values are going to multiply by -2 and add 1. So 0 times -2 is 0, plus 1 is 1. So I plot the point -1, +1. 1 times -2 is -2. -2 plus 1 is -1. So you have 0, -1. And then you have 1. 4 times -2 is -8. -8 plus 1 is -7. So I have 1, -7. And again, it's symmetric through this line. So if it's 2 units to the right, then it's 2 units to the left. Well, that was a bad connect the dots. There we go. So this one's not factorable. If you want the bonus point for tomorrow, if your roots are not pretty points on the table, then you have to use the quadratic formula. So bonus tomorrow is remembering your quadratic formula and finding the roots. So that would be like x equals, in this case it's a little tricky, so I probably wouldn't do it to you because this one does not have standard form. So you would have to have like foiled all of that. So tomorrow, if you need to use quadratic formula, it'll be in standard form. Or if it's in vertex form, your roots will be nice. So don't worry about the roots on this one.